Let's look at some qualities of these virtual warehouses now. These virtual warehouses are elastic and can instantaneously change their size, start, shut down instantly. The first thing we'll talk about is the scale up capability. As you saw, virtual warehouses are MPP compute clusters. Now, this cluster size can be immediately increased to serve a bigger workload. For example, we might have started with the extra small size, but if you suddenly have to process a more complex query or process more amount of data, we can immediately increase this to a bigger size all the way up to 6x large. Most of the times, it takes less than a second up to the sizes of x large, 2x large. In very large sizes, it may take longer, but this process is generally very instantaneous and immediate to increase the size. Now, one thing to keep in mind is this process of scaling vertically, changing the size from a smaller one to a large one, is useful when we want to finish a query faster. We are processing a bigger workload, processing more data, and want to do it faster, then scaling vertically is the way to go. So what we are doing is in the same cluster, we are allowing it to have more nodes, and a single query can be run on multiple nodes, much more nodes than it was running previously. It would have run previously. So this works on any new incoming queries. Any query which is already running on these nodes does not get affected. Any new query which gets submitted, and if it needs more number of nodes, it will go on to run on all those nodes in the cluster. So keep in mind, scaling vertically is required and useful when you are running a complex workload or processing more amount of data and want to finish that query faster. On the other side, you have something called as scaling horizontally. What is happening in this case is, rather than increasing size of one virtual warehouse, we are adding more virtual warehouses. So we are adding more clusters under the same virtual warehouse name. Yeah, and this is useful for handling lot many concurrent users and lot many concurrent queries. So in scaling vertically, we were finishing a query faster, processing a workload faster, and taking more amount of data. In scaling horizontally, we want to take more amount of queries at the same time, which is being fired by multiple concurrent users. That is where scaling horizontally is more useful. So what happens behind the scenes is, I have a virtual warehouse, and as more and more queries start coming in, Snowflake will start spinning more and more clusters under that virtual warehouse. We saw this in the demo as well. When we configure the virtual warehouse, we had the option to do auto scale over there. So that is the scale horizontal piece. Now, in terms of how the cost for this virtual warehouses is calculated, it is calculated based on the number of virtual warehouses being used. So, for example, in this diagram, you can see we have 5 virtual warehouses. How long these are running, how many seconds to be precise, starting with minimum of 60 seconds. If you run less than 60 seconds, you still pay for 60 seconds. And third, size of the virtual warehouse. So if it is extra small, you are paying 1 credit for 1 hour. If it is small, it is double the size of extra small, you are paying 2 credits for an hour. And then it gets calculated based on the number of seconds it has run. And so ultimately we add up all this virtual warehouses cost, each node into the number of credits that virtual warehouse is supposed to consume and the number of seconds it has run. We can go into the more detailed calculation later on, but at high level, these are the 3 parameters used to understand the cost of these compute clusters or virtual warehouses. Now let's look at a summary of virtual warehouses.